everybody. I'm Paige Hattie, the Vice President of Marketing at Mobius Connect, and I'm so excited to welcome you all to our interview for today. We've got Michael Hastings from BK Vibro here with us. Welcome, Michael. How's it going?
Yeah, hi. Hello, everyone. Yeah, nice.
Good. We're so excited to chat a little bit today. So I think we're going to be talking about reciprocating compressors, right?
Yeah,
Awesome. So before we jump into that, Mike, would you mind just sharing a little bit about your background and your role with BK Vibro?
yeah, yeah. I've been with Pool Care Vibro now for 34 years, many years. And I'm an application there, engineer there. And I'm currently working in marketing communications. I do a lot of articles and papers and things like that. But I also do application engineering work as well. And I've done a lot of work with the reciprocating compressor and also hydroelectric generating units, which is not at all related to this reciprocating compressor. But these are two areas where I've done a lot of work in. Yeah.
Fantastic. So I think that sets us up perfectly for kind of continuing the conversation today, Mike. So I think before we jump into things, so I know our topic revolves a lot around the Aviva Pi system. Would you mind, for our audience and our listeners who maybe aren't familiar with the system, would you mind just introducing it and sharing a little bit more about what it is?
Yeah, the Viva Pi system is a historian. This is an enterprise-wide system where it manages data from many different systems, from monitoring systems, from processing systems and control systems, and it's all stored in one location. And this data can be accessed by other systems, for example, to do correlation or to do AI or machine learning. There's a lot of data from a lot of different machines, and it basically avoids having individual database servers for individual monitoring systems, where you can have several different monitoring systems, and then you have to have a monitoring system server and a database server for each of these systems. So it makes data more accessible and is better for diagnostics that way.
All right, awesome. So Mike, tell me a little bit more about why reciprocating compressors is special.
Yeah, I can continue saying that the Aviva Pi system does a lot of things. It basically offers tools for visualization and alarming and notification of these alarms. And it does analysis, and it can work with many, many different machines and processes, and including the reciprocating compressor. But the reciprocating compressor is special in that sense that it has special requirements as far as monitoring goes. There are specialized plots, diagnostic plots, and measurement techniques for the vibration monitoring, for example, for performance parameters and various types of analysis. So this this requires special attention to implement in the historian, and this is because of these special healthcare requirements for the reciprocating compressor.
Okay, great. Thanks, Mike. So would you mind explaining a little bit more about what type of maintenance issues someone could run into when using this type of machine?
Yeah, like I mentioned, the reciprocating compressor is a very special animal. And when you compare it to, for example, rotating machinery like centrifugal compressors or axial compressors or pumps, there's a lot more maintenance issues with the reciprocating compressor. And this is because of the how it operates. I mean, the running gear is creating a lot of stresses on the components because of this reciprocating motion. And so that's the valves moving up and down, and piston rod moving back and forth, and the crosshead as well. And so all this creates a lot of impacts that normally a centrifugal compressor wouldn't be subjected to. So there's a lot more maintenance required on these machines. And but what's interesting is in the industry, even though there's more maintenance required for the reciprocating compressor, it's actually less monitored than the rotating machinery. And there's several reasons for this, but basically it's a lack of understanding of the monitoring techniques, which are very specialized for the reciprocating compressor.
All right. Well, so Mike, maybe share a little bit more about that if you can, about the unique monitoring techniques for the reciprocators, and then how specifically they're implemented with the historian.
Yeah, there are specialized monitoring techniques, and these are used for both detecting, for example, mechanical faults of the components of the piston rod or the rider rings or the crosshead. So there's degradation of components, but it's also used for detecting gas leaks. And now these gas leaks, is contained. In other words, if if the valves are leaking gas, it won't leak out to the atmosphere and create problems there. But it will have an effect on the efficiency of the reciprocating compressor, because it's not producing the capacity, or the production of the compressor is not enough to meet the requirements. So that is an issue when the components are leaking. And basically, the Viva Pi system and other historians, they don't offer tools to do this type of analysis for leak detection. And so, so it requires for the monitoring system to have a special native connection to the historian. And this is important simply because, as I mentioned earlier, the specialized plots are not provided by the historian. So these are provided by the monitoring system provider. But the Pi system allows you to click on a single little icon to open this, so you can see all the plots and the descriptors and the trends as if it were part of the Pi system. But you're actually connecting to the monitoring system for these specialized plots and monitoring techniques. So it's it plays a very important role for the reciprocating compressor to be monitored in the Pi system. It takes in process data as well, which is important as well. So it can be compared, because the process data is also used for doing some of the analysis and the performance calculations to say how well the compressor is doing and how efficient it's operating, and if there's any leaks.
Oh, okay, great. So Mike, would you mind outlining and just elaborating a little bit more with the advantages when it comes to doing this for the Pi system, maybe instead of doing it within the condition monitoring system itself?
Yeah, I mean, like I mentioned earlier when I was talking about giving a description of the Viva Pi system, one of the big advantages is that you have a database for all the monitoring systems in one place. See, if you're using individual monitoring systems, like some are monitoring the pressure, suction and discharge gas pressure, and others are monitoring temperatures, and you can have several different monitoring systems, including that for monitoring the vibration. And they have their individual database servers, and then sometimes it's difficult to get access to correlate this data. But the Pi system makes all this available, and it reduces the need for having all these individual servers. So there's less stress on the IT department, for example, to maintain and upgrade the servers, because you have just the Pi system server, and all the other systems are just delivering data there, and they don't have their own individual database servers. So the other advantage for the using the Pi system, for example, for reciprocating compressors, is that some of the performance parameters And this would be like a theoretical gas discharge temperature or volumetric efficiency. These are calculated values that are based on assumptions and ideal conditions. And sometimes end users will add correction factors to these to increase the accuracy. And so the Viva Pi system, it has analytic tools. That they have a calculation engine that is very easy to use. It's like Excel, and it's transparent. And then you can make changes to the performance parameters to correct for whatever special application conditions are for that particular customer. It may not be the same from one customer to the next. And so for a standalone monitoring system to do that in their own software, to make a change like that, it could be, it could be a year or so to implement it and test it. And it would cost as well, but it can all be done in the Pi system on the fly, and then it can be fine-tuned. After, for example, 2 months, you can see, okay, it's not exactly as we need it to be, so we make a couple changes. So this is just what some of the advantages that the Pi system offers for the reciprocating compressor.
That's great, Mike. Thank you so much for sharing that. And I know it's, we've just kind of covered a brief introduction to the Pi system today, but it sounds like it certainly could be very helpful. And I think how that fits into monitoring reciprocating compressors would be, again, just really valuable to everyone. So is there any way, or how would you best recommend, I guess, that somebody learn more about either the Pi system or about the reciprocating compressor resources? Or how would somebody go about getting in touch with you to learn more and continue the conversation?
Yeah, I can be contacted through my email address, and that is just michael.hastings at bkvibro.com. You can also contact us through our website, and that's bkvibro.com. And you can also find me on LinkedIn, or you can find my name also on the internet, maybe for some of the papers and things I made. But if anyone has any questions or would like to talk more about this, I could help. And then we have specialists as well in the company that could give extra support for both from the reciprocating compressor monitoring solution, and also for managing data in the Viva Pi system and how make everything work together. So there's a lot of support available for that.
That's fantastic, Mike. Thank you so much for your time today. And I know as well, we have a great library of content from BK Vibro and yourself also up on CBM and Reliability Connect that's available. We'll link some of that to this interview here today, so everybody has that as a resource, and we'll also make sure your contact information is readily available to anyone that listened and has questions. But Mike, thank you. It's always a pleasure. Thank you so much for taking the time to be here with us today.
Yeah, thank you, Paige, and you have a good day. And everyone listening, I wish you the best, and please contact us if you have questions.
Thank you.